Okay, so this will be the final review that I'll do with you. Now, guys, anytime you need to predict product, remember you're going to need two things. You're going to need this reactivity table, and you're also going to need your solubility table. Let me grab that. So you've got two tables that you need anytime you need to predict product, these two. Okay, so we're going to start with the first one. And the way we tell which table we need is we look at it, and anytime you have an element, okay, plus a compound, then you're going to look at your reactivity of metals or nonmetals, one or the other, okay, because these are single replacements, okay. So when I go to look at this, I'm comparing my two metals, okay, metal to metal. And so I come to my table and I find barium, which is here, and I find magnesium. So my question is, again, that I ask myself, is barium greater than magnesium? Okay, the single one has to be greater than the compound. Okay, if it's not going to work. So magnesium is right here. Here's barium. So barium is stronger than magnesium. So this reaction is going to take place. So what's going to happen is barium is going to attach to the iodine, and it's going to knock off the magnesium. So barium's charge is a 2+. Iodine's charge is a 1-. So anytime, again, you write your own compound, you have got to check your charges. So I need a 2 there. Okay. The next thing you would need to do would be to balance it. But I have a barium and a barium, magnesium, magnesium, 2 iodines, 2 iodines. So this one is balanced already. Remember, we talked about you either write the word balanced or you put ones out in front. Okay. The next one, we're going to look again. Here's an element and a compound. So I'm going to ask myself, is zinc greater than hydrogen? Is zinc greater than hydrogen? So here's zinc. Here's hydrogen. So zinc is greater than hydrogen. Okay. And so in this case, again, we're just going to swap those out. So zinc is going to bond with the chlorine, and the hydrogen gets knocked off. Now, a couple of things you got to remember here. Hydrogen is one of our diatomics, so we're going to knock it off as a gas. Zinc and chlorine, you're going to need to look up because zinc is a 2+. You should have that marked on your table. And chlorine's a 1-. So I need a 2 there. Okay? So that's the first step. Now I just need to balance it. Again, I have 2 chlorines and 2 hydrogens, but I only have 1 over here. Squeeze a little 2 in place there. Okay? Very good. Okay. So these are both single replacements. That's how we need to do that. Now you need to recognize those. Now this one, if you look at it, this is a compound. That's a compound. So I have 2 compounds. So this is going to be a double replacement. So the double replacement, in order to determine if we have a reaction, we have to look at this table. Okay? But first we're going to do a predicting of products. And if you'll remember, it's just where the iron in this case is a 2+. Now you say, how do you know that? Well, chlorine is a 1-, and there's 2 of them. These have to balance out, so the iron has to be a 2+. Potassium, again, on our table is a 1+. Hydroxide, that's a polyatomic, it's a 1-. Okay, so we're going to do a switch. The positive attaches to the negative. Okay, and the iron again was a 2+. Hydroxide's a 1-. So I need 2 of these. The positive is going to attach to the negative, potassium chloride. Okay, potassium is a +1. Chlorine's a -1, so those are already balanced out. Okay, and then I would need to balance my reaction. So I need 2 of these to get the 2 there. I have 2 potassiums, 2 chlorines. I get a 2 there. Okay, my 2's look really bad. They look almost like Z's. Okay, but in order to determine whether or not it's a reaction, I got to go to my table here and see if I formed a precipitate. So one of these must be insoluble. So I need iron and hydroxide. So let me pull this table up just a little bit bigger so you can see it. So here's iron, and here's hydroxide. So I'm going to just go across, and iron hydroxide is insoluble. If it is insoluble, it means it's not going to break apart, which means it is going to be a precipitate, and we put it as S. So our PPT, our precipitate, we call it a solid. Okay, that's what that S means. That does not mean soluble. It means a solid. KCl, I can look it up, and generally only one should be insoluble. So chlorine, potassium, soluble, which means that this is going to be my aqueous. So I do have a reaction here, okay? Remember, if neither one of these is insoluble, so this one was insoluble, again, so we call it a solid, okay? But if neither one of them are insoluble, then you're going to have a no reaction. So if you were looking at it in whatever, and both of them were soluble, no reaction. Okay, so the rest of it here, again, is just putting it together and translating it. So I'm going to leave the rest of that. You should be able to do those on your own.